Here in this presentation, we will be doing bar diagrams, pie chart, histogram, and other type of geometric representations. The geometric presentations is the first one is the bar diagram. Here the bar diagram consists of the equispaced and equiwidth rectangular bars for each category of the data. The bar diagram is divided into two types. First one is the multiple bar diagram and the second one is the component bar diagram. In the multiple bar diagram, there are comparison of two or more sets. For example, income and expenditure, exports and imports for different years, etc. For the component bar diagram, comparing of different components or parts is shown, and the relationship of the integral parts can also be compared. For example, sales of various products, expenses pattern of families, etc. Now we will see the multiple bar diagram. Here the example is given. Comparing marks of two students in a class. Here in the multiple bar diagram, the two bars represent each subject, one for each student, and the bars are placed side by side for easy comparisons. So in table 5.1, we see the marks of students A and B for the subjects math, science, and computer. Now we see on the right hand side the bar diagram has been drawn for the different subjects of the student acquiring marks for student A and student B. Now we consider the component bar diagram case. In the component bar diagram, the total is divided into different parts. Now, for example, we take the expenses of two families. Here, the category are family A and family B, and their expenses are on food, education, clothing, others, and the total are given. We see in table 5.3 that the expenses of the two families are given. Now we find the component bar diagram here by putting the y and the x-axis accordingly. Here we will see that the geometric presentation of the component bar diagram is given. The next geometric presentation is the pie diagram. In the pie chart or the pie diagram, a circular chart is presented where it is shown how the total is divided into different parts, where each part is the sector of the circle. The pie chart shows the percentage of each of the component in the total. The formula to draw the pie chart is required to convert the values into the angles. So the angle of the sector is equal to value by total into 360. Here we find the monthly expenses in table 5.5 given for every item. So the items are food, education, and clothing, and the monthly expenses are 2,000, 2,500, and 1,500. So the pie chart is drawn accordingly. We will find how to draw the pie chart in the next slide. In order to draw the pie chart, first we will have to find out the angle for each of the sector. So from the formula, angle of sector is equal to value by total into 360 degree. And from the reference table 5.5, we find angle 1 is equal to 2000 by 6,000, which is the total value of the monthly expenses, 2,000 plus 2,500 plus 1,500, which is 6,000 into 360. So angle 1 is 120 degree. Next one is angle 2, which is the monthly expense of education as 2,500. The total expenses is 6,000, which is multiplied by 360 degree, which comes up to 150 degree. And angle 3, which is clothing, which is 1,500 by the total expenses, which is 6,000 into 360 degree, which is 90 degree. So angle 3 is 90 degree. Now to get the percentage for each of the angle, we calculate it by taking the degree by dividing it by 360, and then multiplying it by 100. So the first will be 120 degree by 360 degree into 100. So the value will be the first percentage. Same thing we do for angle 2 and angle 3. Now the steps to draw the pie chart. The first we will have to draw a circle with a compass. Then we will start from any reference line, which is the radius. Then using the protractor we will mark the angles. Then draw the sector one by one. Next we will shade the different angles with different colors or with different shades. Then we will add the legends and the levels, so we can easily draw the pie chart with these steps. Thank you. The next geometric presentation is the frequency curve. The frequency curve, we have histogram as the first frequency curve. So histogram is the two-dimensional diagram which displays the data is distributed across the class interval. The shape of the data can be predicted very well from the histogram. Now, in the given example in table 5.7, we find the number of students securing marks as per the class interval. So from 0 to n class 10 class interval, we find 5 number of students. From 10 to 20, it is 9. From 20 to 30, it is 10. From 30 to 40, it is 8. From 40 to 50, it is 18. Now we draw the histogram accordingly. Here we find the histogram of the number of students for each of the class interval represented very easily. In the next video, we will be continuing doing with frequency polygon, ogive and arithmetic line graph. Thank you.